So let's continue the questions for this chapter, the course questions. State the type of hybrid orbitals, the shape and the approximate measure of the bond angles present in the following molecules. The BeCl2. What is the method to know the hybridization? In any molecule like BeCl2, where there is one central atom and two atoms around it, which is known as AX2, when we have drawn the PeCl2 molecule, we found that it's made from one central beryllium atom. It has 2 electrons only, no lone pair of electrons around it, and the chlorine has 7 electrons, 6 electrons as lone pairs, and 1 electron joined to the beryllium atom. We have agreed that anything that has 2 atoms around the central atom is a linear shaped molecule, and that its angle will always be 180 degrees. What if we have BCl3? This time, by drawing the electron dot diagram, we will see that the beryllium has 3 chlorine atoms around it, and there is no lone pairs or any other extra electrons because boron has only 3 electrons. So that's one central atom and 3 atoms around it, and this shape has an angle of 360 divided by 3, so it is 120 degrees, and we call this shape the trigonal planar. It's all by memorizing. While CH4 has a central atom and 4 other atoms around it without any lone pair of electrons, so this is the carbon attached to 4 hydrogen atoms. The only way to do this is by the tetrahedral shape. The angle is 109.5 degrees, and the correct way to draw this one is by trying to draw a 3D shape of this one. This has connection to 4 hydrogen atoms. One is pointing towards me, this is that one, and one is at the back side, and one is planar with this one on the same plane. And the angle is 109.5. This follows for any molecule which has AX4. The shape of water is one central atom with 2 atoms around it and 2 lone pair of electrons. So X2E2, anything like that is called a bent shape. We call it a V-shaped also, or nonlinear shape. And the angle for this, the smallest angle we set for the bend is 104 degrees. The last one is the NH3. The NH3 and the shape of any molecule that has one central atom and 3 other atoms around it and 1 lone pair of electrons, so it is AX3E, is a trigonal, but this time it's not planar, it's trigonal pyramidal. So the pyramid shape, and the angle for this one is 107 degrees. What should I do by this, mister? I should memorize anything that's AX2. So if I have CO2 also, it's still linear. AX3, so if I have BF3, one central and 3 around it, no lone pair of electrons, only bond pairs, it is trigonal planar, and the angle has to be memorized. CCl4, one central atom and 4 atoms around it without any lone pair of electrons. Tetrahedral 109.5, H2O bend shaped, H2S. So the same thing, it has one central atom, 2 atoms around it, and 2 lone pair of electrons. So it's V-shaped or pen-shaped and 104.5. Trigonal planar, if you have phosphorus and 3 hydrogens, that's the same thing. You have 1 lone pair of electron and 1 on a central atom and 3 other atoms. It's trigonal pyramidal and 107. What about the hybridization of the orbitals? How do you know this? We know already the measure of the angles, the shape, but how about the hybridization? To know the hybridization, you have to check how many things are around the central atom. Is it how many things, how many electron clouds, how many electron pairs? So if this is a carbon and around it one thing, this is we call one electron cloud or one pair of electrons. Is it 2? Is it 3? Is it 4? That's how you know the hybridization. Mister, this is nitrogen. It has how many things around it? This is oxygen. How many things around it? So let's see the examples that we have. If you have a BCl2, you have the central atom with two things around it. Things means either lone pairs or bond pairs. So I have two bond pairs around it. If you have two things around the central atom, then your hybridization is sp2. It's an sp hybridization. So you have just to subtract one and then memorize this way to do it. You have two things, subtract one, so it is sp1. If you have three things, subtract one, so it is sp2. If you have four things, this is three things. How is three things? This is bf3. So three pair of electrons around three pairs. Where are the three pairs? That's 1 and 2 and 3. Here you have two pairs only. If you have four pairs, then you again subtract 1 and it will be sp3. This is just to memorize it like that. Two things, two pairs, then sp, three pairs sp2, four pairs sp3. If you don't know what's sp and sp2 and sp3, just go back to the video of the explanation of hybridization. But you will mostly be asked to know the name of the hybridization only. You will not explain how did this hybridization happen. If you have more complicated structures, let's see. So here I have PCl3, PCH4. This all has no lone pairs. If you have H2O, the H2O is like that. We agreed that the drawing is 1, 2. So now how many things you have around the water molecule? You have how many bond pairs and lone pairs? I have here one bond pair, two lone pairs. This means that you have a total of four pairs. This is 1, 2, 3, 4. Two lone pairs and two bond pairs. And we explained that if you have four things, four pairs, then you have an sp3. So H2O is an sp3 also. This is sp3 and this is also an sp3. What about NH2? NH3, I mean. This is again 1, 2, 3, 4 pairs. So it's still sp3 hybridization. Anything that has, you have to look out for the central atom. This is the most important thing. The people tend to get lost here. This is molecule, and he asks you in this big molecule to look for the hybridization. He will not ask you about the hybridization of the atom. He will ask you about the hybridization of a certain atom, not all the molecule like that. So if you are looking for hybridization here, you have to ask yourself, where is the hybridization of carbon, of oxygen? So if you want to know the hybridization of carbon, then you have to take the carbon out. This is the central atom, and this is the things around it. 1, 2, 3, 4 bond pairs. For carbon, this is four things. If you have four things, you have sp3. So it has an sp3 hybridization. What about the oxygen? The oxygen has two pairs around it only, 1, 2, and you said if you have two, then it is an sp hybridization. So what is the sp hybridization of, what is the hybridization of carbon? It's sp3, of oxygen, it is sp. Another molecule looks complicated, C double bond O, and then C, and then H, and then H, and then H, and then OH, carboxylic acid. What is the hybridization? Don't get confused. See it one by one. So he is asking about hybridization of this one. This, let's call it carbon number 1, carbon number 2, and then oxygen. So three things. So don't say the hybridization of the whole molecule of this atom. So C number 1, C number 2, and oxygen. C number 1 is 1, 2, 3, 4 things around it. Mister, this is double bond, but it's still considered as one thing. So it is 1, 2, 3, 4. So please take care. If you have one thing, one single bond or double bond or triple bond, they are considered as one thing around this atom. So can you count how many things are around this carbon? There's three things now, and this is 4. So it's still 4 things. Mister, but there is single bond, so it is 4. What if it is double bond? I have here 1, 2, 3. So how many things around this? It has 3. But this is double bond. It's not counted as 2. It's counted as 3. So here 3 and here's 4. What about this one? It has two things around it. Mister, but this is triple bond. It's still counted as one thing. So I have two things around here only. So this is sp3, this is sp2, this is sp. Again, anything with four things around the central atom is sp3. Anything with three things is sp2, and here 1, 2, so sp only. Mister, what about the second carbon? 1, 2, 3. So three things. 1, 2, 3. So this is three carbons. We said that this is sp has four things, so it is sp3. Here has three things around it, so sp2. What about the oxygen? Has two things around it, so only sp hybridization. The last part in this section is talking about something called a dative covalent bond. What is a dative covalent bond? Until now, in all the covalent bonds that we have explained, the bond is between two different atoms, let's say X and Y, and each bond is made by joining two electrons. The two electrons are coming from two atoms, so this one has shared one electron and this has shared one electron. What if you have double bond? Then we agreed that you have four electrons. So two from this side and two from this side. What if you have three bonds? Then again you have 6 electrons. So 3 from here and 3 from here. What is if the bond is made by joining or sharing electrons that are shared from one side only? So let's imagine that the X has shared the two electrons and Y has given nothing. So if the dative covalent bond is done by sharing two electrons are shared from where? It's only shared from one atom only, So there are still two electrons, but they are shared from one atom only. The easiest way is to get familiar with the examples. So I have NH4 here. The NH4 is made from three atoms and one hydrogen proton. The hydrogen proton is an H which came without any electrons. It is called a proton because it just has a proton inside it. It's called H+. So NH4 plus comes from NH3 plus one hydrogen. So this one joins here, but how it joins? It has no electrons to make the bond. But don't forget that the hydrogen has lone pair of electrons. So it will use this lone pair of electrons to make the bond. And we will make an arrow to keep the hydrogen remembering all the time that the electrons that made the bond came from it. Another example is BF4. So the boron has fluorine, fluorine, and fluorine. You want to make another fluorine to join, but this boron has no more electrons. It has only 3 electrons, so it cannot join to any other extra fluorine atoms. If you brought another fluorine atom, this fluorine can use its extra lone pairs. It has 1, 2, 3, 4, 5, 6. It can use one extra electron to make a bond. So if you brought fluorine with one extra electron, means that there is not only 7 electrons in the lone pair, but there is one extra. So it will use this extra electron to make a bond. It doesn't share its normal electron only, but it shares one extra bond. So here, this came with 1, 2, 3, 4, 5, 6, 7 electrons. This is the normal electrons of the fluorine, but it has one extra. That's why we say BF4 minus. So you didn't get fluorine 4, you get BF3 plus 1 fluorine minus. It has, the normal fluorine has 7 electrons, 1, 2, 3, 4, 5, 6, 7. This one will have one extra. So now it can use these 2 electrons to make a bond. So the 2 electrons will be shared between the fluorine and the boron. Why? Because boron has no electrons to make an extra bond, but fluorine now has 2 electrons to make the bond. And then we'll draw the arrow to make the boron always remember that the electron came from the fluorine. This is the structure of BF4 minus, and this is the structure of NH4 plus. So only get familiar with the molecules. Also, there is H3O plus. So if water has 2 hydrogen atoms attached and it wants to join one more proton, the water has 2 lone pair of electrons. It can use one of them. It will keep one of them aside and use one of them to make an extra bond with the proton that came. So this is the structure of H3O plus. The easiest thing to always remember and know the dative covalent bond. This is the bond that is made covalent bond made by sharing two electrons from one atom only. So the electrons came from the oxygen, came from the nitrogen, came from the boron. This arrow shows that where did the electrons come from? It didn't come from two atoms like here. It came from one atom only.